Okay, so we're wrapping up cross-linking and then just kind of trying to talk about the differences between branched versus cross-linked and how that changes the properties of some of these plastics. So um, the rest of the questions, and I'm moving over to page 310 now, really just talks about how chemists and people in the industry want to control how much branching there is. They also want to control how much cross-linking there is. Maybe they want something that's really branched with cross-linking. What kind of plastic is that going to make? Is it going to be really dense and hard? Is it going to be stretchy? What's up with that? Maybe they don't want branching. Maybe they don't want cross-linking. Maybe they only want one of them. And so people in the industry have figured out ways to alter these polymers that they get from petroleum to make different plastics that suit lots of different purposes, which is kind of neat. So the last couple questions here, number 8 says to draw several aligned linear polymer chains. So here's some aligned linear polymer chains. Parallel, they are not linked. It didn't say anything about linking. They're not branched. So think of like skinny spaghetti noodles all lined up together, okay? Kind of slippery in that sense. 9 says to say, okay, we'll take those aligned polymers and link them up. So here they are, aligned, but cross-linked. So I just put my little squigglies in there to show that cross-linking. Here is the difference between those two, okay? And then number 10 says, okay, well, let's explain the difference, all right? So, well, obviously, if something's cross-linked, it's going to be stronger. It's going to be more rigid. So polymers that are cross-linked are stronger. They're less ductile. That means that they're not stretchy. They hold on to each other more. So you can't like stretch them out like taffy or like some gummy candy, okay? And then number 11 says, for what types of products could the materials made from the polymer you drew in number 8 be used for? Well, number 8 is this non-linked linear material. Well, obviously, the type of plastic you're going to make with something like this is going to be something that needs to be stretchy, right? But also strong, because these guys are really close together. They have lots of intermolecular forces holding them. So this is going to be a really strong plastic, but it's also going to be really stretchy because there's no links holding it together. So you can kind of slip these past each other with that type of plastic. Okay, so ductile and strong in that sense. And then the last question here just says, all right, well, let's talk about types of plastic. You have LDPE, which stands for low density polyethylene. And then you have HDPD, which stands for high density polyethylene. Well, what's the difference between those? How do you get low density? How do you get high density? And the answer in that question is how much branching. If you have lots of branching stemming off, remember those plastics are really far away from each other. They have, where's my example here? These guys, they aren't all compacted together like these guys here. Without the branching, you get them all squeezed in nice and, linear, organized. You can cram a lot more plastics in with the linear no branching than you can the branch. So the branched polymers are less dense, okay? They take up more space. They have more empty space in between them that's not being used. So branched polymers are low density. So we get the LDPE from the branches, pushing it out, kind of making more space there. Well, then the opposite. The HDPE you get from non-branch polymers, okay? They can compact. You get more matter crammed into a certain space. So for that last question here, HDPE is less branching, okay? LDPE is more branching, all right? And I'm going to send pictures of these to kind of help you guys out with that, all right? I hope that helps. Send questions my way.